Hey everyone, welcome to the third video in the new team's Onshape introduction series. In this video, I'll be running through the tips and tricks that I picked up while modeling the accumulator, as well as the notable points from the Onshape learning pathways and courses. By now, you should all know the drill. I won't run through the basics of assemblies, as the required learning pathways will have covered them. I'm just highlighting some potentially elusive concepts. I should also note that this video does contain a couple of things which are absolutely essential for everyone to watch, just to make sure that we don't have a bunch of failed assemblies on our hands with no clear reasons as for why. With that out of the way, let's get started. Alright, so here we are in an Onshape assembly. You should all be aware that you can assemble parts, surfaces, sketches, and other assemblies within your assembly. So at the moment we've only got two parts in here, and I'll start off with the first tip. So I think that you guys would have seen that you have to start off an assembly by fixing a component. Even though it's an option, you should absolutely never fix more than one of your components. It should always start off with basically a parent component. So what I'm going to do is I'm going to click anywhere on the BMS right here, and I'll drag this triad until it snaps to the center. And then I'm going to right click the center of that triad and say move to origin. Fantastic. Alright, now I'm going to click on that part and press fix. Excellent. So now that's fixed in place. I can't drag it anywhere. So that's always the first step, and make sure you only do that with one component. The next step obviously is to mate these two components, and that brings us to the first big topic of the video, which is mate connectors. The first thing to note is that mates and mate connectors are not the same thing. These tools here are all mates, whereas mate connectors are the red, green and blue things that look like that. So mate connectors are just some significant point on a part that we can use as a reference when joining two components together. It can be one that Onshape guesses for us, or one that we define ourselves. And a mate is just the type of joint between two different mate connectors. So for example, fastened, revolute, cylindrical, everything like that. A mate connector has a complete knowledge of a part's orientation and position. A handy shortcut to hide and show all mates is K. It doesn't seem that significant in this one because there's only one explicit mate connector, but that's fine. So an important thing to note is that a mate connector has a primary axis and two secondary axes. So the primary axis is the Z axis, and it's the blue axis that kind of sticks out from the face of the white circle. The red and green are the X and Y, and they are kind of the secondary axes. They're not quite as important. So when that becomes a big deal for us to understand is when we start using these mates. So when I use a mate, I can hover over a part and it'll show me all of the significant parts of the geometry that I might want to mate to. If I've defined any explicit mate connectors, like the one down here, I can also use that as well. So for this part down here, I'll have a look at the underside, and you can see that if I just put my cursor somewhere on this face, I get a ton of different mate connectors here. Usually for something that isn't too position critical like this, I'll just have a look for this sort of black and white one that denotes the center of the face just in here, and I'll select that. I should also note that I'm holding shift at the moment to kind of lock all of these mate connectors on screen, so even if I move my cursor away, they still stay there. Anyway, so I'll use that selection there. So I've selected one mate connector while using the fastened mate. The next step is choosing the corresponding one on the BMS. So I'm just going to go down in here. Once again, I can see the black and white circle that denotes that is the center of this face. Now, something that we should realize is, it's not very clear right now, but you can see the Z axis, the primary axis, sticking up from the face there. It corresponds on this other component. When I selected the first mate connector there, it was pointing into the component. So we actually got fairly lucky in that the two primary axes actually correspond to what we want here. Now we can see that these secondary axes do not correspond. It's turned 90 degrees to how we want. So I can use this button, the same button is up here, and I can flip that. Now it's fairly likely when you're selecting your primary axes that it'll be oriented in the same plane but the wrong direction, and that's what this button down here is for. So you can see that that's flipped. I've still got the same sort of plane that the primary axes are in, but just different directions. Excellent, so I can now tick that. Now let's explore the case where perhaps the primary axes are not aligned how you want them to be. So I've just pasted another instance of that connector down there, and I'm going to try out another fastened mate. I might grab one of the corners of this piece down here and maybe the corner of the BMS up here, just for the ease of demonstration. So once again, you can see that the Z-axis is kind of pointing straight out from the BMS, and it's got the corresponding thing. The Z-axis down here is pointing out from the part. So potentially that's what we want, potentially it isn't. Let's have a go. Wonderful. All right. So obviously this mate makes no sense. I'm just using it for demonstration. So initially I'll flip that primary axis around, but let's say that that's actually not the plane that we want the primary axes to live in. We have the option to use this offset tool up here. So I can try playing around with these tools, but you can see that it's only giving me a very limited number of options here. If I use the offset tool, then I have a lot more flexibility in terms of translation and rotation of this mate connector. So I can actually have it such that it is aligned with the x-axis pointing into the BMS rather than the z-axis. So I can rotate about y by 90 degrees. Let's try. Wonderful. So you can see that that's now given me x-axis pointing out instead of the z-axis. So I've almost changed what my primary axis is. There are two ways to do this. You can either do it at the mate level, which is what I've just done here, or I'll swap to this one here. Excellent. So now that that's loaded, I can actually define one of my own mate connectors instead. So you can see that if I grab one of the corners, it doesn't really matter which one. If I grab it, by default, the mate connector wants to sit with its Z-axis, the primary axis, pointing out of the face that I just chose. Usually that's a pretty fair assumption, but perhaps it's actually not what I want for this time. So instead of realigning it while I'm mating it, instead I can realign it at the part level with this mate connector. And I can say primary axis entity, and instead of it pointing out from this face, I can have it lying along that edge, for example. You can choose edges. You can also choose datum planes and that sort of thing. So that's actually the same one, so that's boring. I can choose front, and it'll orient normal to the front plane, or I could choose the right plane, for example. I like using the datum planes as direction references because they'll never change. If you use an edge on a part and then you change the geometry or add a round to that edge or something like that, it may not survive. But yeah, so this is another option. So now I would be able to use this mate connector while mating in the BMS assembly, and I wouldn't have to realign it while I'm mating. I could basically just use that mate connector there. All connections have 6 degrees of freedom, 3 translational and 3 rotational. Each mate locks between 2 and 6 of these. For example, the fastened mate locks all 6 degrees of freedom, so the part can't translate or rotate. So you can see I've applied a fasten mate down here, and when I click and drag, nothing happens there because it's locked in every direction. The revolute mate, however, it locks all 3 translational, but it leaves one of the rotational degrees of freedom free. So around the Z-axis, I can actually twist and rotate that part, but as you can see, I can't rotate it in any other direction other than that one there. Beautiful. And the last example that I've got here is the parallel mate, which I guess you could say is one of the weakest mates. It basically just says that 2 faces have to be parallel to each other, unsurprisingly, and it leaves all other degrees of freedom free. So I'm actually able to translate this in all 3 directions, and I can rotate it about the Z-axis as well. So on the Onshape cheat sheet, I've put a bit of a reference down here for all the different mate connectors and their degrees of freedom. So you can see the fastened has no degrees of freedom, and the parallel has 3 translational and 1 rotational. You are able to use more than one mate to constrain a part, but you should try and use as few as possible. It can be useful to use multiple when you need more flexibility with your degrees of freedom. Say if you needed 3 translational degrees of freedom but 0 rotational. You can also use multiple mates if you need to constrain your part to more than one other part. The second example here, where you need to reference more than one other part, this is because when you're mating, you have to grab another mate connector when constraining. Mate connectors can only belong to a single part, and you can't grab more than one reference mate connector per mate. So that's an instance where you'd need more than one. And the fuse that we can see here is a good example of where I've actually needed to use this. So this slot here, I care about the center of this slot being a nice even number of millimeters from the edge of this plate here, just to make it easier for machining. And I also obviously care about the fact that the face between the fuse and the face between the relay should be touching. So how do I achieve this? In Creo, I would be using 3 distance or coincident constraints. And in Onshape, that's basically the same thing as using 3 planar constraints, either with or without offsets, depending on if I'm doing distance or coincident. In Onshape, I'd like to use as few mate connectors as possible, but since I have to constrain from 2 different components here, it's not conveniently possible to just use 1 mate connector. So what's the best approach? Well, to answer that, I've drawn a pretty diagram in the Better CAD system over here. So you can see I've got the red, green and blue principal axes marked out with translational and rotational vectors there. So in terms of how we want to approach this, I usually start with looking at the most complicated interaction. So for us, that would be the interaction between the fuse and the relay over here. The alternative is I could have a look at this interaction between these 2 faces, but that's not really that interesting at the moment. So I'll start with the most complicated one, and we'll start by asking what we know. So in terms of what degrees of freedom this interaction has to lock, we know that it has to lock the red translational because this thing isn't allowed to move up and down. It'll have to lock the green translational as well because we don't want it to be able to move side to side. And then for the blue translational, it won't lock that one because that will be defined by this interaction here. And then for rotational, it doesn't matter too much which one of these interactions takes care of it, but I'll start by looking at the most complicated one still. I'll have a look at the relay. So we know off the bat that blue isn't allowed to rotate because it has to sit flush on that air. We also know for the same reason that green won't be able to rotate. And then in terms of red rotating, it really doesn't matter whether that's taken care of by the relay or the top plate. For now, I'm going to put it under relay, but it really could go in either. And so then looking at the other mate, the one that will exist between the fuse and the top plate over here, we know that that one has to take care of the blue translational degree of freedom. So that's all of our degrees of freedom taken care of. Once again, pretty much all the rotational ones could be taken care of by the top plate mate as well. But at that point, we're just looking for a bit of redundancy. So where I go from here, I have a look at how many degrees of freedom I've got. So for this bottom mate here, I can see that I've got only one thing missing, which is the translational degree of freedom. So we want 1 degree of freedom in the translational and 0 degrees of freedom in the rotational. If I jump over to the cheat sheet, we've got 1 degree of freedom in the translational and 0 in the rotational when we use a slider mate. So the slider mate's probably pretty appropriate for the mate between the fuse and the relay. As for the other one, we're going to have a look at the top plate. So the top plate has 2 degrees of freedom in the translational, and we're not too concerned by rotational because that's going to be taken care of by the relay. So if I go back, we're looking for 2 degrees of freedom in the translational, and we don't really care about the rotational. So that's achieved clearly by the planar, which has 2 degrees of freedom there, and once again, don't really care about what that is. So a planar and a slider mate are probably going to do us pretty well here. So if I go back to my assembly, I'll drag this out so it's a little bit clearer. So we'll start with the slider mate. And I want the face of the relay and the face of the fuse to be mated together. So for this one, I'm actually going to put it on this face and making sure that it's touching the bottom there. So this should be pretty clear as for why it works in a moment. I'll do a corresponding thing over here. So in a slider mate, the primary axis is the one that is allowed to translate. So in this case, the Z axis. So when I click that there, the fuse snaps to it. I'll click the play button, but I think it's actually going to move the relay, even though, oh, no, there we go. So it's moving the fuse, and you can see it's locked all degrees of freedom other than that translational one, which is the one that we want to be set by the other mate anyway. So that's exactly what we want. I'll say tick for now. Excellent. So now I'll just drag this roughly into the right position, about there, just so we can see the mate connector on it. I will show that mate connector. Wonderful. So then if I want to apply the planar mate, I can grab that one there. Once again, the only reason why I defined an explicit mate connector here was so that I didn't have to grab one of these ones here and rotate it after the fact. So I can just grab that one there, and I can grab any of the mate connectors on this face. It's kind of logical that I can choose the center one, but I could also choose one of the corner ones here. So for now, I'll grab the center. Fantastic. And then if I go solve, it locks it there with the center of this thing locked to the edge of that plate there, which is not actually what I want. I want there to be an offset there. So this is, once again, in Creo, the same as using a distance constraint. I'll try moving it, I don't know, 32 millimeters, and that's moved it the wrong way. So I'll just chuck a negative there. And when I hit solve, it should snap to the final position, and that's pretty good. That's about where I want it. So that's how you can use multiple mates to constrain a single item when you need to constrain it using multiple reference pieces. Once you're in an assembly and you've mated up a whole bunch of things together, it can be really useful to be able to edit those mates later on without having to scroll through your enormous feature list down here. So if you want to edit that, all you have to do is click on the part, right click, and click show mates, and then you can see the ones that we've got there. So I can click on that and it'll bring it to me in the list there. So that's really convenient when you've got quite a lot and you need to just quickly edit one. So mate connectors can be used for a lot more than you might initially think. If I place one sort of out in some free space here, I'll use move, and I'll move it 30 millimeters that way and 30 millimeters that way. Excellent. So I can then use that mate connector as an axis if I want to do a circular pattern there. So it's quite a versatile tool, so I could obviously move that mate connector to anywhere in free space. I wouldn't have to, select one of these axes here or something that already exists. I can kind of place my own. You can also use mate connectors as a sketch plane. So if I want to sketch, I can select an explicit mate connector and just start going. It'll always use the XY principal axes as your plane. Alternatively, I can choose an implicit mate connector as well by using this button here. And I can choose anything that Onshape wants to give me there. Excellent. If I have chosen an implicit one, I can also realign it and move that mate connector as well if I need to. So I can do 50 mils out that way. I can realign it. The primary axis, I can rotate, in any direction that I want by any amount that I want. So you can place some very obscure planes wherever you need to, just using mate connectors. You can also use mate connectors for mirror planes. So if I exit that sketch and I want to mirror, I'll just say that I'm mirroring a part for now, but for mirror plane, you can see this button down here as well. So I can once again just select any implicit or explicit mate connector that I want. I can then once again realign it however I want to. Just showing a bit of an example here. So you can really do whatever you need to with mate connectors. There's a lot of versatility with them, and they're quite a neat solution for a lot of problems that you might not have thought about. Alright, so the next lot of tips that I'm going to give are actually extremely important. They cover some things that I thought weren't that important when I first started going through, but I started noticing a lot of issues popping up in my accumulator assembly and I couldn't explain why. So it basically relates to inserting parts from a part studio. So as most of you will know, you can either insert a single part, multiple parts, or an entire part studio at once into an assembly. So I'm just going to pretend that these two parts don't exist yet. So I will suppress them. All right. So then if I go to insert my part studio and I'll grab the BMS parts, all of that part studio there, I'll just hit the green tick so it gets placed in the default placement. Excellent. So all of those parts have been placed in the correct orientation and position relative to each other. I know that because I modeled them over here, so obviously they look identical for the moment. However, I can still grab and drag these ones here because they haven't been fixed in any way together. So what we can do when we've inserted a bunch of parts that, you know, there's no clear sort of mate between these orange cables and anything else here, what I can do is I can use the group tool here, and I can select all of the components that I want to group, go tick, and now they can't move relative to each other, which is probably exactly what I want here. The next step is to grab one of my parts here. I will grab that triad and say move to origin and then fix. Wonderful. Okay, so that seems like a pretty robust solution for a lot of things, but grouping can be very dangerous. So we should never use groups in a top level assembly. It seems kind of counterintuitive because sometimes you would be inserting an entire part studio into, you know, the accumulator, for example, but there's a bit of a glaring issue with doing that. All right, so here I am in the accumulator assembly. You can see I've got my BMS down here, which is already part of its own subassembly. I've hidden the parts that I'm about to insert. We're just pretending that they don't exist in there at the moment. So what I'm going to do is I'll insert that part studio from before, BMS parts. Excellent. And you can see that if I don't try and move them around out here, if I just kind of leave them on the green dot, they go to the right position because I modeled them from the accumulator context, which is fantastic, except as we discovered before, I haven't actually fixed anything in place. All of these things can still move around independently of each other and independently of the rest of the accumulator. So the first step that I would do is I would select all of these and I would drag them all into the BMS assembly, like so. So they don't actually move in the modeling assembly, but in the model tree over here, you can see, oops, wrong one. You can see that we've got those 3 new parts there. Great. All right, so now what would be very tempting is to group all of those things. So if I try to use group and I grab those things there, it doesn't quite work because it wants me to use an entire assembly. I can't just group individual components, but that's fine because it'll still work the same. So if I group the entire BMS assembly to the segments assembly, and I go OK, wonderful. So nothing's moved far that I can see. If I try and click and drag on this stuff, it's all locked in place. And this particular geometry would actually be quite difficult to use a mate connector with. I don't think the corners down here actually directly correspond to anything down there. This blue clip is some distance away from the edges there. So it could actually be quite difficult to try and assemble this and then use mate connectors to mate it in place. That being said, now that I've inserted that group, we've got a bit of a problem because this group applies to the whole subassembly that you've kind of used for it. So in this case, it applies to the entire BMS assembly and the segments assembly. And what the group does is it essentially locks every single component in those assemblies in place so they just 100% can't move. So if I open up my BMS assembly now, and I'll try inserting another part into this because maybe there was something else that I want to just insert from here rather than the accumulator. I don't know, for some reason, let's just insert an energies module. Cool. All right, now I'll just do some dumb mate between the 2 of these. Excellent. So you can see I've got that energies module just sort of sticking out from the edge of the BMS. If I go back to my accumulator assembly, you can see we can't actually see that energies module poking out. If I try and find where it is in this model, you can see it is for some reason buried way down here, even though I've used the mate connector in here and it's, you know, I'm trying to click and drag it, I can't move it. And that's because the group that we used in this top level assembly groups all of these assemblies in, and that means that every single component is locked in place. So when I inserted this Energist module, wherever it kind of instantly snapped to, this group interpreted that and went, oh, we've got a new component, let's lock it in place so it absolutely can't move. And so it doesn't matter what I do in here, I can't get that component to sit in the right place. So it can be really dangerous, because if you're just mucking around in this assembly, you may not actually realize that it hasn't translated up. So the band-aid solution for this is I can suppress the group and then we can watch it snap to the right place, and then I can unsuppress it and everything is fixed in place. So like I said, that's a bit of a band-aid solution. It doesn't scale very well, and having to unsuppress and resuppress all your groups is really bad. But also, generally speaking, it means your model tree is just going to be really gross if you've got tons of groups of different components and everything like that. But there is a better solution, and even when you have geometry like this that's quite organic and difficult to mate to, there are a couple of tricks that you can adopt to make it a lot nicer for yourself. So in the BMS Part Studio, like I mentioned before, I modeled that from an accumulator context, and we'll be discussing in-context relationships again shortly. But there's a bit of a trick that I've found that can actually really help when it comes to mating this sort of difficult and organic geometry. So if I go to create an explicit mate connector, I'm going to put it on some bit of significant and obvious geometry that's unlikely to change. So I have typically been using just the very outer corner of this furthest wall here. So I've placed it. Now I need to decide what the owner part is. Doesn't really matter. I'll just choose whatever the top part is in my assembly. So I've placed a mate connector, what seems like out in free space, and it now belongs to that BMS clip there. So I'll go tick, I'll hide that context, and you can see we've just got a mate connector out there. So then in the accumulator, I'll delete this group here. I'll actually go into my BMS assembly, and I'll hide all of these duplicate parts from the first time I made this assembly. Excellent. All right, so now this is actually quite an appropriate place to use the group tool. I'll group all of these things together because this is not a high level assembly. I don't need to group these connectors down here because they've been mated. Excellent, so now nothing can be clicked and dragged and moved. Now I've pretended that I haven't already assembled the BMS in this assembly. I actually have in the real version of this, but just for demonstration I'm pretending that I haven't. So at the moment I can drag all of these components around, which is not what we want, and it's potentially going to be very difficult to find a logical mate connector to use. So what we can do is we can use the mate connector that we've defined. So it's actually showed up here, so you can see that mate connector is the one that we made that belongs to the mounting clip. So we can make, I might actually just drag it out a little bit to make that mate connector a little bit clearer. So I can then use a fastened mate between the mate connector that we made and the exact same mate connector from the exact same place on this edge. Terrific. And so then if we zoom out, you can see that everything has gone into its correct place, and we didn't have to use the group tool in this high level assembly. So now if we decide to add more components into that assembly, we won't have random failures and things floating out in the middle of nowhere. When we were having a look at this assembly earlier, you probably would have noticed that I used a copy and pasted this component and did 3 different mate connectors down the bottom. That's a bit of a dumb way to do it. This is a really good application for the replicate tool. So I can choose the part that I want to replicate, and then I can choose the part that has the reference faces for the original mate, and you can see that it picks them out exactly as I'd want them there. The next thing is if I wanted to create a new subassembly from these ones, I can select all of them, right click, and you can see I've got 2 options here. I've got move to new subassembly and create new subassembly. If I use create new subassembly, it doesn't actually move them for me. I have to click and drag all of them into that assembly there. Alternatively, if I want to automatically move them into the new subassembly, I can use the move to new subassembly button. The next couple of tips that I've got are all about showing and hiding parts. So if you click on a part and press Y, it'll hide that part. You can also click on it in the model tree and go Shift Y to show it. You can do that with a lot of things at once. So I can kind of grab a whole bunch of things here and go Y to hide them. Once again, I can Shift select. You can also access all of this through the right click menu. So you can do show, you can do hide, and vice versa. That's all pretty simple. Something that I really enjoy is the isolate tool. So you can right click on a part and hit isolate. And first of all, it'll just show kind of itself with ghost mode and everything else. And then this expand connectivity option that basically says I will start showing things that are mated to it first. So if I go once, this nut here is mated to the air assembly and to the fuse as well. I can keep dragging that out and it'll show gradually more. So the air and the fuse are then mated to this top plate, and I can keep dragging it along and it'll eventually show everything. I can also go with expand distance, and that's pretty clear. It just shows things as it gets further and further away. Another cool tip, just for saving yourself some time, is that if you want to go to the part studio for a particular part, you can right click on it and go switch to top plate. Alright, so the next lot of tips are actually, once again, very important for everyone to watch to make sure that we get a consistent fastener library across the entire car. So Onshape has something similar to Creo. Creo had the intelligent fastener tool. Onshape has this standard content library. So it's got a few things, bolts and screws. It's got most of what we need, but not enough to really get us over the line. I got very frustrated very quickly with the limited options and how long it kind of takes to get this menu working properly. So I've made our own fastener library for everyone to use. So essentially all you have to do is insert from another document, and then you can kind of filter through and you can go new racing, EV3, miscellaneous fit and finish, fasteners, and then you can choose the assembly from here. A faster way to get to this is by going in your documents, opening it all up, navigating to that particular document, and then as soon as you've opened it once, then you'll be able to find it in your other documents recently opened. Fasteners will be right at the top there for you. So if we want to insert a fastener, like I said, you always want to use the assembly. None of the part studios here, always use the assembly. Doesn't matter if you want just a nut or nut, bolt and washers, just always use the assembly. Hey guys, quick pause for a second here. I realized in the video I said that you should never use one of the fastener library part studios. You should exclusively be using the assemblies. And for the most part that's true. However, there will be some instances where you don't actually need a bolt, such as in here, and you would only need a nut. If that's the case, you can actually use the part studios there. So recently opened fasteners. So normally I would go in here and insert a nut and bolt, but right now all I need is a nut. So doing this, it's the exact same as it is for the assembly. Right now I want an M10 nut, so I can put in thread diameter 10. I can also insert a washer, but keep in mind this is a part studio. The nut and washer will appear to be in the right place and linked together, but they'll just be floating. So if I grab that nut there, excellent, go tick. So those seem to be linked together, but I can just drag the washer away. So just be wary if you're using the part studios, because that can happen. So you can see here I've got the option to click on this fastener assembly here, and I've got a few options down here as well. So I can choose cap head or hex head. We can obviously add more later if we want. You put in your thread diameter, so currently this is M3. I think I might change that later, but I'll leave it for now. And at the moment I have the options for a nut ticked, but I don't have any washers. So if I wanted to change this, I'll keep it as cap head for now. I'll change it to M5 and I'll make it something weird, I don't know, 13 millimeters. And I actually want a bolt, I want a bolt head washer and a nut washer. So you can see now that the generate button is popped up. This will only pop up if you've made changes to these configurations here. If you haven't, then you can just immediately click the name. Since I have made changes, I'll hit generate, let it do its thing, and then I can click the fastener assembly button. And it populates that there. I'll go tick for now. Alright, so what have we got? At the moment, you can see we've got a nut, a couple of washers, and a bolt, a couple of washers, and a nut. This nut is constrained to move on the axis of the bolt, so it can't actually move anywhere else other than that. Obviously, we haven't constrained the bolt to exist yet. So what we can do, we can apply a fastened mate from this washer onto the hole that we've got up here. Terrific. I'll go solve, and I can see that's actually gone the wrong way. I'll flip that around, go solve. Excellent. So the bolt head is placed. So now if I have a look once again at the nut, so the nut is still free sliding, which is not what we want. We want it to be assembled so that it's coincident with the interface of this accumulator here. So I'll drag it out a little bit. I only let it come out 10 mils past the end of the bolt for whatever size you're using. And then I can use the planar mate to constrain the face of the washer to the surface of the accumulator container. I go solve, and there we go. So that's how to use the fastener library. If you decide, actually, no, that's not the right bolt that I want to use, all you have to do is right click and go change configuration. And then you have the option to change anything that you want from here. You can untick and tick these options, so on and so forth. When inserting parts or assemblies or anything else into an assembly that you're working on, you're not constrained to only insert things from the current document. You can insert things from other documents, which is exactly what we do when we're inserting fasteners, as I showed you just before. And the important thing to note when you're inserting something from another document is it's referred to as a linked document, and in order to do that, the linked document has to have an established version. So I've actually done quite a lot of changes in the fasteners. You can see we're up to the 69th version there. And the other important thing to note is that if you insert something from a version document and you make a change in that document, it won't automatically flow on through. Now, this is actually a good thing. It means that we won't have unexpected changes. So right now you can see that we've kind of got that cap head there. I'll now make a change to that cap head. I don't know, I'll just do a random extrude from the front plane. Once again, just something to kind of show that we've got a change happening here. Wonderful. All right, so obviously that's a nonsense part. If we go into our assembly, we can see that that change has come through there. Fantastic. And if I go into my assembly, that hasn't actually changed. Nothing has happened there. If I try to insert another fastener, it will prompt me. It'll say that there have been 2 changes since the last version, so that was the sketch and the extrude, so it gives me the option to create a version. In general, it's best to create the version from the document because then you know what the changes that you've made are. So if I was to create another version here, excellent, so that's reflected on through. So at the moment, there's still no change to this cap head bolt, even though we've made another change to that, even though we've made a change to the original document. However, this button up here has become highlighted, and we've also got a notification down here saying new versions of linked documents are available. So I usually use this one up here, and I choose all of the things that I want to be able to update. In this case, the only thing for us to update are the fasteners here, so I can go update all. Excellent, and you can see that that change has now been reflected through. So when people make surprising changes that you weren't quite ready for, this way it doesn't kind of reflect on through to all of your assemblies and break everything. So the most obvious application for linked documents is actually going to be in EV3 and probably all the other new teams assemblies as well. Our main assembly is going to be one document where we insert all of our other documents. So at the moment, the accumulator is its own document, and I'll be inserting this document into the main assembly document. So then when I make changes to this particular setting, it doesn't flow on through to the main assembly until I'm ready. When you are ready for changes to flow on through, it's important that you don't use the update all button that I just did in that top menu there. That's because it'll update everyone's documents there, and that's maybe not necessarily what they're ready for. So only ever update your documents or documents that you're sure have changes that you want to keep. Something else that I'll mention is that I've updated the fasteners library again, and you can see that I've got outdated linked documents. So I can use this button here, or I can right click on my particular tab and go update linked document, and it takes me to the same thing. However, the big difference is if you do this from the main assembly and use this button up here, then I can select to update fasteners, and every single tab that uses that gets involved in the main assembly will also have its fasteners updated. Whereas if I go through and I update that one, and then I update that one, I go through all of my other tabs and update everything that has an outdated reference, it'll take me a long time. Alternatively, like I said, you can just go to the highest level assembly, use this button here, and it'll drag all of those updates through all of those sub-assemblies. You can tell when something is part of a linked document because it has this symbol here right next to it. You can also insert an old version of a part if you need to. So if I use the fasteners again, go in here, assemblies, so I can choose the latest version, which is what this will pick, or I can go into this version graph here and choose any one of the old versions in case I started doing something substantially different and I just want to have a correct model using one of the old versions if I need to. Anyway, that's all the tips that I've got for Onshape assemblies. Hope you guys enjoyed. I'll see you in the next video.